When solving systems, one method is called substitution, and in this case it's just what the name implies. We have one equation that already is solved for a variable, in this case y. Y is equal to x plus 2. So what we want to do is we want to plug in x plus 2 and replace y. So I'm going to write 3x plus, in parentheses, x plus 2. Now, if you've noticed, in this equation, I have no y's. Therefore, when I solve the equation, I'm solving for x. So, normally you will see a coefficient right here. In this case, it's 1. And you would distribute to both, or to whatever's inside the parentheses. In this case, since it is 1, it's just going to be x plus 2. So I can write 3x plus x plus 2 and get rid of the parentheses. Now I'm charged with combining like terms. 3x plus x is 4x. Bring down your plus 2 equals 10. Now I have a one variable equation, so I'm going to solve for x. I'm going to subtract 2 from both sides. I end up with 4x is equal to 8. I then divide by 4, and I find that x is equal to 2. Well, I'm then going to use this and plug it back into one of my original equations. Since my top equation is already solved for y, I'm simply going to write it down, x plus 2, and I'm going to substitute the x for 2. So this right here is now going to replace this x right here. So y equals 2 plus 2, and you get y is equal to 4, giving you a solution of 2, 4. Sometimes your variable you can solve for the y, but in this case, if you notice, I already have an equation solved for x. So what I'm going to do is I'm going to plug y minus 2 in for this x, and when I do that, I get 2 times y minus 2 minus y equals 5. Now, just like in the previous problem, it had a 1, but in this case I have a 2. So I put it in parentheses, and now I'm going to distribute that 2. 2y minus 4, and then bring down your minus y equals 5. Notice I've gotten rid of the parentheses once I've distributed that 2. Well, now I'm going to combine like terms. Well, 2y and negative y combine to give me y. You have done nothing with the negative 4. Remember, you've only combined like terms, 2y and negative y. So on the same side. Well, then I'm going to add a 4 to the mix on both sides, and I end up getting y is equal to 9. Now, again, I'm going to plug in to one of my equations. And I can plug it into either one. This one is already solved for x, so I'm going to plug in the 9 for the y. So again, I'm going to have x equals 9 minus 2, and x is equal to 7. Therefore, I have a solution of 7, 9. Sometimes when you have two equations or a system and you're going to solve by substitution, as in the previous two problems, one of the equations in each problem was already solved for. Like for instance, in the first one, y was already solved for. And the second one, x was already solved for. So in this case, I have to solve for one of them. Well, I'm going to choose this one here. It looks to be the easiest of the two because it has a coefficient of 1. So what I'm going to do is I'm going to solve for y. I simply have to add x to both sides, and I end up getting y is equal to x plus 4. Now, because I've already solved for this variable, I can now plug that in to this y. So I end up getting 2x plus 3, and instead of y, I'm going to write x plus 4 equals 27. Then, just like in the previous problem, I'm going to distribute that 3, and I get 2x plus 3x plus 12, because 3 times x is 3x, 3 times 4 is 12, equals 27. I'm then going to combine like terms. So 2x and 3x combine to give me 5x, bring down your plus 12 equals 27. Next, we're going to solve for x. So I'm going to get rid of the 12, and I end up with 5x equals 15. And 5 times what gives me 15? Well, the answer will be 3. Now, remember, I have to solve for y. So I can, since this equation here is the same as this equation here, it just looks differently because one is solved for y and one is not. I'm going to plug in x right there. So I end up getting y is equal to 3 plus 4, and that is equal to 7. Therefore, I have a solution of 3, 7. Now remember, you could have still plugged it in to the original equation, which looked like that. It doesn't matter because this equation here and this equation here are both the same.